Now equation of plane passing through three non-collinear points. If there are three non-collinear points, then a unique plane is defined. As for example, on the surface of this blackboard, if I keep these 3 points, these 3 points are non-collinear, and here there exists a plane. Means surface of this blackboard itself is a plane containing these 3 points. If suppose I keep these 2 points as it is and third point is somewhere here in the space, then you can imagine a plane passing through these 3 points. Say this plane is containing these 2 points as well as this third point. So here in 3 dimension you can imagine. If third point is somewhere here, so you can imagine plane like this, which is including these points as well as this point. So anywhere if there are 3 points which are non-collinear, suppose these 2 points are here, third point is somewhere here. So these are non-collinear points, hence there exists a plane containing these 3 non-collinear points. So first condition for existence of unique plane is points must be non-collinear. If points are collinear, if all the points lie on the same line, then there exist infinite many planes containing these 3 points. This surface of green board itself, you can imagine a plane like this. You can also imagine plane like this. See, all these planes are containing these 3 points, like pages of a book. All the pages of book are passing from a line where it is bounded. So here, to obtain a vector and the Cartesian equation of plane, let me take this plane. This plane is passing from 3 points A, B, C. These are non-collinear points. Suppose that position vector of suppose origin, O is origin. That means somewhere here this is x-axis, this is y-axis, here this is z-axis. Then suppose position vector of point A is vector A, position vector of point B is vector B, position vector of vector C, position vector of point C, suppose it is vector C. 3 non-collinear points are given, 3 points whose position vectors are given. These points determine a unique plane, so we can put equation of this plane. So equation of this plane, its vector form is vector equation. Here vector equation of a plane passing through three non-collinear points whose position vectors are vector A, vector B and vector C, whose position vectors are vector A, vector B and vector C. So vector equation of such plane is vector R minus vector A dot vector B minus vector A cross vector C minus vector A. It is equal to 0. So it is dot product of vector R minus vector A and this vector is cross product of vector B minus vector A, vector C minus vector A. This is a vector equation of plane if three non-collinear points are given. So here, if B minus A cross C minus A, if this is not equal to 0, then these points are non-collinear. A, B, C are non-collinear. If this is not equal to 0, in this equation, this will be not equal to 0 because points are non-collinear. But if you find vector B minus vector A cross vector C minus vector A, if cross product of these two vectors is 0 vector, this is non-zero vector. Cross product is a vector. If cross product is 0 vector, then points are collinear. And in this case, infinite many planes pass through given 3 points. Now, Cartesian form of this result of this equation. Now Cartesian form. Cartesian equation of a plane passing through 3 non-collinear points x1 y1 z1 comma x2 y2 z2, and third point is x3 y3 z3. So equation is, now see, you can remember equation from this result. This is, suppose this is vector x dot vector y cross vector z. So keep a determinant. I am putting here a determinant. Determinant equal to 0. Determinant equal to 0. In first row we keep components of vector r minus vector a. See, in this whole chapter, vector r, that is position vector of variable point. Vector r, always we take xi plus yj plus zk, variable point. P is variable point whose position vector is vector r. The whole chapter, vector r, we are taking xi plus yj plus zk. So r minus a. So r minus a, this you can consider components of vector a. So r minus a, that is x minus x1, y minus y1, z minus z1. Then vector b minus vector a, keep in second line. So vector b minus vector a, so b minus a, so x2 minus x1, y2 minus y1, z2 minus z1. Third line, vector c minus vector a, c minus a, that is x3 minus x1, y3 minus y1, z3 minus z1. So this is Cartesian form of equation of line, equation of plane passing through three non-collinear points. Find the equations of the planes that passes through 3 points. Here there are two questions. First of all, we check a plane passing through these 3 points. See, coordinates of points in space are given. These are 3 points in the space. So let me take position vector of this point. Position vector of this point is vector A. It will be 1i plus 1j minus 1k. Position vector of second point is vector B. It is 6i plus 4j minus 5k. Position vector of third point is vector C. Vector C is minus 4i minus 2j plus 3k. So these are position vectors of 3 given points. Now first of all, we check collinearity or non-collinearity. Are these 3 points collinear or non-collinear? For which we find vector B minus vector A and vector C minus vector A. Vector B minus vector A, that is 6 minus 1, 5i, 4 minus 1, 3j, minus 5 plus 1, minus 4k. Here C minus A, that is minus 4 minus 1, minus 5i, minus 2 minus 1, minus 3j, minus 5 plus 1, 3 minus minus 1, that is plus 1, plus 4k. So it is vector C minus vector A. Now see, if we find cross product of these vectors, then it will be I, j, k. Say look here, 5, 3, minus 4, minus 5, minus 3, 4. So I into 12 minus 12, that is 0, minus j into 20 minus 20, 0, plus k into minus 15 plus 15, that is 0. So this is 0 vector. So therefore given points are collinear. Therefore given points collinear, and because given 3 points are collinear, there does not exist unique plane. Therefore there does not exist unique plane from given 3 points. That means there are infinite many planes passing from these 3 points. So because no unique plane exists, equation is not possible. Now in this question, again these are points. We take vector A is 1i plus 1j plus 0k. Vector B is 1i plus 2j plus 1k. Vector C is minus 2i plus 2j minus k. Now we find vector B minus vector A cross vector C minus vector A. So see, vector B minus vector A, then vector C minus vector A. Vector B minus vector A, that is 0i plus 2 minus 1 is 1j, 1 minus 0, that is 1k. Vector C minus vector A, so minus 2 minus 1 minus 3i, 2 minus 1 1j, minus 1 minus 0 that is minus k. Then we find b bar, vector b minus vector a cross vector c minus vector a. So it is equal to I j. See, we are performing similarly. So vector b minus vector a components are 0, 1, 1. Then here minus 3, 1, minus 1. So that is, it will be minus 1, minus 1, minus 2i minus j into 0 minus minus 3, that is plus 3. So 3j plus k into 0 minus minus 3, that is plus 3. So 3k. So this is not zero vector. So points are non-collinear. Therefore, given points are non-collinear. And because given points are non-collinear, there exists a unique plane. So equation of plane, therefore equation of plane in vector form, it will be, formula is r minus a dot b minus a cross c minus a equal to 0. Say this is a dot product. Dot product is a scalar. So here it is a 0. So vector r minus vector a. Vector a is I plus j plus 0k means nothing. So this is r minus vector a. Put in bracket dot product of cross product of these two vectors is here already found, minus 2i minus 3j plus 3k. This is equal to 0. So this is vector equation. Which is vector equation? Which is vector equation. Now for Cartesian equation, we can continue in this equation. For Cartesian equation, therefore, now see, from this we can continue to get Cartesian equation. Method is, vector r is xi plus yj plus zk. So if we keep here x, y, z, then this vector is for continuing this calculation, continuing by considering vector r xi plus yj plus zk. Continuing this procedure, say this will be then x minus 1 times I, y minus 1 times j, and z minus 0 times k. Close the bracket. Dot minus 2i minus 3j plus 3k equal to 0. So get vector r minus vector a by considering vector r as xi plus yj plus zk. So this is taking a dot product, minus 2 into x minus 1. So minus 2 into x minus 1 plus minus 3 into this number, minus 3 into y minus 1 plus 3 into z minus 0 equal to 0. That is minus 2x plus 2 minus 3y plus 3 plus 3z is 0. That is 2x plus 3y minus 3z equal to 5. So this is Cartesian equation. And if you don't want to continue from vector equation, then second method is to get Cartesian equation, alternate method. Now see, second method for Cartesian equation. In second method, we call these points as x1, y1, z1, x2, y2, z2, x3, y3, z3. So we take x1, y1, z1 equal to 1, 1, 0, x2, y2, z2 equal to 1, 2, 1, x3, y3, z3 equal to minus 2 to minus 1, and required equation is, formula is determinant x minus x1, x y minus y1, z minus z1, here we keep equal to 0, here x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. This is Cartesian form. Now putting values, x minus x1, x1 is 1, y minus 1, z minus 0. Then x2 minus x1, so x2 minus x1, so here 1 minus 1, 2 minus 1, 1 minus 0. Then x3 minus x1, x3 minus x1, so minus 2 minus 1, 2 minus 1, minus 1 minus 0 equal to 0. Don't forget to continue this equal to 0, equal to 0, equal to 0. So that is equal to x minus 1, y minus 1, z minus 1. Here 1 minus 1 is 0. This is 1, 1. Here minus 3, 1, minus 1 equal to 0. Now simplifying this, x minus 1 into minus 1, minus 1, that is minus 2. So I keep here minus 2. Minus y minus 1 into 0 minus minus 3, that is plus 3, plus z minus 1 into 0 minus minus 3, so minus 3, that is plus 3, z minus 1 into 0 minus minus 3, that is plus 3 equal to 0. Say we are getting same, y minus 1, sorry, I have done here mistake, y minus 1 minus y minus 1 into 0 minus minus 3, that is plus 3. Okay. So this is, we are going to get same equation. See, so its simple form is 2x plus 3y minus 3z equal to 5. It is required equation. So if you are asked to find Cartesian equation, only if you are asked to find Cartesian equation, if 3 points are given, then this method is better. Now next result, intercept form of equation of a plane. Intercept form of equation of a plane. That means, say in the space, let me take this line x-axis, this line is y-axis, this line is z-axis. Suppose there is a plane which cuts this coordinate axis suppose this plane cuts x-axis in point A00, y-axis in point 0B0 and z-axis in point C00C. Then here A, B, C are intercepts made by this plane. X intercept is A, Y intercept is B, Z intercept is this small c. So if intercepts made by plane are small a, small b and small c respectively, that means first number is x intercept, second number is y intercept, third number is z intercept. Then equation of such plane is, equation of plane is x upon a plus y upon b plus z upon c is 1. This is intercept form. As for example, suppose question is obtain equation of plane whose intercepts are 2, -3, 4 respectively. Obtain equation of plane whose intercepts are given. So say here x intercept is 2, y intercept is -3, z intercept is 4. So these are intercepts. Now putting in this equation, so required equation is x upon a plus y upon b plus z upon c is 1. Putting values in this equation, required equation is x upon a plus y upon b plus z upon c equal to 1. Now putting this in simple form, we multiply this by 12. So multiplying by 12, 6x minus 4y plus 3z equal to 12. So this is required equation. As for example, suppose question is obtain equation of a plane. Suppose equation is given x by 3 plus y by 5 plus z minus z by 1, or let me take only minus z equal to -3. Obtain equation of plane, sorry, I have to change this equation. Obtain equation of plane 3x minus 4y plus z equal to plus 9 equal to 0 into intercept form. Obtain equation of this plane into intercept form and obtain intercepts So say here this equation is 3x minus 4y plus z plus 9 equal to 0. We want to convert this into this intercept form. This is intercept form. So first of all, we have to set on right hand side +1. +1 is required on right hand side. So here 3x minus 4y plus z equal to -9. So constant shift on the right hand side. Now because here we need plus 1, first of all we change sign. So minus 3x plus 4y minus z, negative is converted into positive. So this sign are changed. Now dividing by 9, minus 3x by 9, 4y by 9, z by 9 equal to 1. So that is, it is x upon minus 3 plus y upon 9 by 4 plus z upon minus 9 equal to 1. This equation convert into this pattern. Terms are separated by plus sign. So this minus is arranged with this number which is in denominator. This minus is arranged here. So x upon a plus y upon b plus z upon c is 1. So here intercepts are minus 3 comma 9 by 4 and minus 9. These are intercepts. In this equation, if you want only intercepts, it can be obtained very easily. If you keep y and z 0, 0, whenever you need intercept, put y 0, z 0, so you will have x intercept. So if you keep here y 0, z 0, so what is x? X will be minus 3. That is second method. In equation 3x minus 4y plus z plus 9 equal to 0, to obtain x intercept, put y and z both 0. To obtain y intercept, put x and z both 0, and to put z intercept, put x and y both 0 in this equation. So directly orally we can calculate intercepts. Now find equation of a plane with intercept 3 on y-axis. Y-intercept is given and parallel to ZOX plane. We show in diagram. Say this is x-axis, this is z-axis, and here this is y-axis. Now plane is a parallel to ZOX plane, parallel to ZOX plane, ZOX plane. That means if this line is here, this line is x-axis, then line perpendicular to this corner, it is z-axis. So ZOX plane parallel to ZOX, that we can consider flooring of this room or ceiling of this room. Ceiling of room can be considered as a plane parallel to ZOX. So let me show in diagram. Suppose here this is the plane which is parallel to ZOX. You can imagine ceiling or like flooring like this. Here ZOX plane, and this is parallel to ZOX plane. It cuts y-axis perpendicularly. Because parallel to this ZOX plane, it will be perpendicular to y-axis, and y-intercept is 3. So coordinates of this point are 0, 3, 0. So plane is passing from 0, 3, 0, and Now its normal can be seen. We can take this vector as normal. See, normal to this vector, this is normal. So this vector we can take 0i plus 3j plus 0k. This is a perpendicular to this plane. So here plane is passing through 0, 3, 0. So a point is given. It's normal to given plane. We say normal n. This can be taken as 0i plus 3j, 0i plus 3j plus 0k. This can be taken as normal. So consider these numbers as A, B, C. This is x1, y1, z1. So here x1, y1, z1, that is given point 0, 3, 0, and A, B, C are 0, 3, 0, same 0, 3, 0. This is A, this is B, this is C. This is x1, y1, z1. See, normal can be taken any vector which is perpendicular to this plane. If you don't want to take 0, 3, 0, you can also take 0, 1, 0. Unit vector. 0, 1, 0 can be also taken. 0, 2, 0 can be also taken. 0, 5, 0 can be also taken. Any perpendicular vector can be taken. We are taking 0, 3, 0. So here equation of plane is A into x minus x1 plus B into y minus y1 plus C into z minus z1 is 0. That is A into 0 into anything is 0. A into x minus x1, x1 is 0. B is 3, 3 into y minus y1 is 3. C is 0 into z minus 0 equal to 0. So this is simple. 3 times y minus 3 is 0. So y minus 3 is 0. This is required equation, or y equal to 3. So see, any plane parallel to x, o, z whose y-intercept 3 is simple, y equal to 3. So shortcut is, if a plane is parallel to x, o, z plane, then equation contains only y. It doesn't contain x and y. As for example, suppose if I give here one more question, changing words, find equation of plane with intercept 5 on z axis, intercept 5 on z axis and parallel to XOY plane. Is, say, plane is parallel to XOY plane, so equation doesn't contain x, it doesn't contain y, equation contains only z. So put z equal to 5 or z minus 5 equal to 0. Here what we have taken, y equal to 3, simple. This was detailed procedure, this is shortcut. Say in 3-dimensional geometry, y equal to 3 represents a plane. In a two-dimensional geometry, y equal to 3 is equation of horizontal line. In three-dimensional geometry, it is plane. If I simply write, suppose x equal to -2. So in two-dimensional geometry, this is equation of vertical line. But in three-dimensional geometry, this is equation of plane whose x-intercept is -2 and which is parallel to YOZ plane. So keep remember this point. Now next result is equation of a plane passing through the intersection of intersection of two planes is a line. So equation of a plane passing through the intersection line of given two planes. This is the result now we are discussing. First of all, we discuss about vector form. Say if this is a plane, given plane, and this is another given plane. These are two given planes. When two planes intersect, their intersection is a straight line. So here this line is intersection line. Suppose equation of this line is equation of this plane is vector r dot n1 equal to d1, and equation of this plane is vector r dot n2 equal to d2. These two planes are intersecting and this is their intersection. Intersection is a line. Now from this line or from intersection, other than these two planes, there are so many planes which are passing. So many planes which are passing from this line. And we can imagine like this. See, this is a plane passing from same point of intersection. This is one more plane which is passing from point of intersection. So many planes we can imagine passing from this intersection line. So equations of all these planes can be found. So first of all, result in vector form. So equation of plane, equation of all the planes. There are infinite many planes. Equation of all the planes passing from intersection of this, we are talking about vector equation. Vector equation of all the planes passing from intersection of given planes. Given planes are vector r dot n1 equal to d1 and vector r dot n2 equal to d2. These are given planes. Formula is vector r dot vector n1 plus lambda times vector n2 equal to d1 plus lambda times vector d2. So this is formula to find vector equation of plane passing from these two planes whose equations in vector form are given. Now we can also put its a Cartesian form. Same result in Cartesian form. Second, Cartesian form. Statement is, if Cartesian equation of all the planes passing from intersection of given planes. Now given planes, its equations I am putting in Cartesian form. Suppose first plane is a1x plus b1y plus c1z plus d1 equal to 0, and second equation a2x plus b2y plus c2z plus d2 equal to 0 is a1x plus b1y plus c1z plus d1 plus lambda times a2x plus b2y plus c2z plus d2 equal to 0, where lambda belongs to R. In this result also lambda is any real number. Lambda belongs to R. As you change value of lambda, changing lambda every time, every new value of lambda gives a new plane. In this result also, see, these parts are fixed in equation. From equation, take this part, put here. But before taking this part, check whether this must be, RHS must be 0. In both equations, RHS must be 0. So whatever is LHS, put here in this result. So these parts are fixed. Lambda, every time changing value of lambda, every new value of lambda gives new equation. If you put here different 100 values of lambda, you will get 100 equations. 100 equations of 100 planes passing from this intersection line. So this is Cartesian form of equation of all the planes passing from intersection of given two planes. Now we are taking question on this result. Find the vector equation of the plane passing through the intersection of the planes. Say these two planes, intersecting planes are given, and through the point 2, 1, 3. Say, meaning of question is that if two planes are given, this is plane 1 and this is plane 2. Suppose these two planes are given. Then when two planes are intersecting, here intersection line is formed. And from this line, there are infinite many planes passing from this line other than these two planes. These two planes themselves are passing from this line. But there are many planes like this. These planes are passing from this line. Infinite many lines can be, infinite many planes can be imagined like this. So many planes are passing from this line. But we need a particular plane. There are many planes. In the family of these infinite many planes, there will be a plane, unique plane. It will be containing this point. So here, if this line, from this line, like this, there are infinite many planes passing. Here see infinite many planes passing. But if a point 2, 1, 3, suppose somewhere here, this is 2, 1, 3, then see, if you imagine this plane then this plane is not passing from 2, 1, 3. If you take this plane, it is not passing from 2, 1, 3. If you take from this line, if you take this plane, it is not passing. But here you can imagine a plane. From this line, here there exists a plane like this. This will be including this point. Here is 2, 1, 3. So this plane is passing from 2, 1, 3. So this is a unique plane. We need equation of this plane. So method is, say here, vector r dot, this is n1, vector n1 is 2i plus 2j minus 3k. This is vector n1. d1 is 7. Vector n2 is 2i plus 5j plus 3k. This is n2. Vector r dot n2 is d2. d2 is 9. Suppose that required plane is, required plane is vector r dot vector n1 plus lambda times n2 equal to d1 plus lambda times d2 by formula. And because there exists a unique plane, so lambda will have some particular value. So for some lambda, this is for some lambda, some particular value of lambda, it can be any real. So lambda will have some particular value to get that particular plane containing that point. So now in this equation, putting values, vector r dot, now vector n1 is 2i plus 2j minus 3k plus lambda times n2 is 2i plus 5j plus 3k, close the bracket, equal to d1 is 7, d2 is 9. So lambda into 9, that is 9 lambda. That is vector r dot, now here 2 plus 2 lambda, now joining this together, addition of vectors, 2 plus 2 lambda, 2 plus 2 lambda times I, 2 plus 5 lambda times j, minus 3 plus 3 lambda times k. So minus 3 plus 3 lambda putting at first place. So 3 lambda minus 3 times k, close the bracket, equal to 7 plus 9 lambda. Now here vector r, what is vector r? So we are now taking vector r is xi plus yj plus zk. So dot product of this vector with this vector, it is on left hand side. So therefore 2 plus 2 lambda into x, so 2 plus 2 lambda into x plus 2 plus 5 lambda into y plus 3 lambda minus 3 into z. So this is a dot product of these two vectors. It is equal to 7 plus 9 lambda. Now, so see here we are getting like ax plus by plus cz equal to d. Now this is passing from 213. This plane passes through point 213. So because this plane is passing from 213, this point will satisfy this equation. So we are allowed to keep x equal to 2, y equal to 1, z equal to 3 in this equation. So putting in equation 1, putting there 2, so 2 into 2 plus 2 lambda, put y equal to 1, that is 2 plus 5 lambda, then put z equal to 3 here, so 3 into 3 lambda minus 3, it is equal to 7 plus 9 lambda. If any point lies on any plane, then coordinates of that point will satisfy that equation. So therefore, this means 2 into 2 4 plus 2 into 2 4 lambda, 2 plus 5 lambda, 9 lambda minus 9 equal to 7 plus 9 lambda. This will be cancelled. So that is 5 lambda plus 4 lambda is 9 lambda, 4 plus 2 is 6, 6 minus 9 minus 3, minus 3 take on this side, so plus 3, so this is 10. So lambda is 10 by 9. Lambda is 10 by 9. Now 10 by 9, this value of lambda we are putting in this equation. This is a vector form. This equation is in vector form, or we can put in this form. Here we can keep lambda. We are putting, let me say this equation is equation 1. This is equation 2. So putting value of lambda in equation 1, putting in 1, vector r not here 2 plus 2 into lambda, put lambda 10 by 9, so 20 by 9, 20 by 9 times I plus 2 plus 5 lambda, so lambda is 10 by 9, so 50 by 9, so 2 plus 50 by 9 times G plus put here 10 by 9, so 10 into 3, 30 by 9, 30 by 9 minus 3 times K equal to 7 plus 9 lambda, 7 plus 9 lambda, so 90 by 9, 9 into lambda, 9 into 10, 90, 90 by 9, that is, so this value of lambda we have taken in this equation, which is vector form. We are asked vector form, so we have taken in this equation. So vector r dot, this is 18 plus 20, 20 plus 18, 38 by 9 times I plus 18 plus 50, 68 by 9 times J plus, this is 3 by 9 times K equal to, this will be 7 plus 10, 17 This can be taken as a vector form of plane. We can take this 9 outside and multiplying 9 on that side. This can be also taken in more simple form. 38i plus 68j plus 3k equal to 17 into 9. So 17 into 9, that is 90 plus 63, 153 equal to 153. This is required vector form of required plane. Find the equation of plane passing through intersection of these two planes. See, equations are given in Cartesian form. We want equation of plane passing through intersection of these two planes and this point. Instruction is find the equation. Here we are not given find a vector equation. If no word given vector equation, we shall find Cartesian equation. So here we are finding Cartesian equation. So here given planes, that plane is 3x minus y plus 2z, constant take on left side, minus 4 equal to 0, and second plane is x plus y plus z minus 2 equal to 0. Always constant take on left side. Here constant take on left side. Here already constant is on left side. This is 0. Otherwise, if RHS is non-zero, take on left side. So in both equations, RHS must be 0. Now, required plane is equation of plane which is passing from intersection of these two planes is, it can be obtained by a1x plus b1y plus c1z plus d1 plus lambda times a2x plus b2y plus c2z minus d2 equal to 0 for some value, particular value of lambda. Let me say this is result 1. Now, family of all the planes passing from intersection of these two planes can be obtained by changing values of lambda, but our required plane is a particular plane passing from these two points, this point. So required plane is passes through particular point 2 to 1. So this will satisfy equation of plane. So therefore, putting this 2 to 1 in this equation, so 3 into 2 is 6 minus put 2, 2 into 1 is 2 minus 4. Here we have taken 2 to 1 plus lambda times put 2 to 1, so 2 to 1 equal to 0. So this is minus 2 plus 2 cancel, 6 minus 4 is 2 plus here plus 2 minus 2 cancel, 2 plus 1 is 3, 3 lambda is 0. So lambda is minus 2 by 3. Putting minus 2 by 3 in equation 1, putting in 1, (3x minus y plus 2z minus 4, lambda is minus 2 by 3, x plus y plus z minus 2 is 0. So simplifying this, so taking LCM, 3 into 3, 9x minus 3 into 3y plus 3 into 2, 6z, 3 into 4 minus 12 minus 2x minus 2y minus 2z plus 4 equal to 0. That is, it is equal to 9 minus 2, 7x minus 3 minus 2 minus 5y 6 minus 2, that is 4z, minus 12 plus 4 is minus 8. Take minus 8 on other side, that is plus 8. So this is required equation. Now find equation of plane through the intersection of these two planes and which is perpendicular to x minus y plus z equal to 0. Say here given planes are x plus y plus z, one shift on left side, minus 1 equal to 0. See again in this question words are find equation. Here words are not that, find vector equation, vector word is not given. So we will find Cartesian equation because values are also given in Cartesian form. So x plus y plus z minus 1 is 0. Second equation is 2x plus 3y plus 4z. Take 5 on this side, minus 5 equal to 0. These are given planes. So equation of plane passing through intersection of given planes is, formula is a1x plus b1y plus c1z plus d1 plus lambda times, put this part with lambda, 2x plus 3y plus 4z minus 5 equal to 0. Whenever we use this result, always keep remember RHS must be 0. Here 0 is must. Then and only then you can use this Cartesian form result. So now required plane will be the plane for some particular value of lambda. For some lambda belonging to R, it will be required plane. Now required plane is perpendicular to this plane. And when two planes are perpendicular, whenever two planes are perpendicular to each other, then their normals are also perpendicular. See, these are normals. Normal to plane 1, this is normal to plane 2. So planes are perpendicular, that means normals are also perpendicular. So their dot product will be 0. So here we will use dot product. So to get normal of this plane, more simplifying, this is 1 plus 2 lambda times x, 1 plus 2 lambda times x, 1 plus 3 lambda times y, 1 plus 4 lambda times z, and minus 1 minus 5 lambda, minus 1 minus 5 lambda. Taking minus common, this is 0. So this is equation of plane in ax plus by plus cz equal to d. This can be shifted on other side, so this will be then positive. So here normal to required plane, we say it is n1. Vector n1 is 1 plus 2 lambda times I plus 1 plus 3 lambda times j plus 1 plus 4 lambda times k. These coefficients of x, y, z are direction ratios of normal. So this will be normal vector. And normal to given plane, normal to given plane, that is vector n2. Now what is given plane? This is given plane. Given plane is x minus y plus z equal to 0. This is given plane. Its normal is, see, 1 minus 1 1. So 1i minus 1j plus 1k. This is normal. But required plane and given plane are perpendicular. So here dot product of n1 and n2 will be 0 because they are perpendicular. So this means n1 dot n2 is 0. Now taking a dot product of these numbers, 1 into 1 plus 2 lambda is 1 plus 2 lambda plus minus 1 into this number, that is minus 1 plus 3 lambda plus 1 into this number is 1 plus 4 lambda. This is 0. We have taken dot product of these two vectors. So that is 1 plus 2 lambda minus 1 minus 3 lambda plus 1 plus 4 lambda is 0. Therefore 4 plus 2 is 6. 6 minus 3 is 3 lambda. This 1 is cancelled. This 1 you take on next other side, so it is minus 1. So lambda is minus 1 by 3. And this value we are putting in equation 1. So putting in 1, here x plus y plus z minus 1, lambda is minus 1 by 3 into 2x plus 3y plus 4z minus 5 equal to 0. So that is now 3x plus 3y plus 3z minus 3 minus 2x minus 3y minus 4z plus 5 is 0. So 3x minus 2x is x. 3y, this will be cancelled. 3z minus 4z is minus z. Minus 3 plus 5 is plus 2 equal to 0. So this is required plane.